And welcome back, students. Let's get into our next lesson. We're continuing kind of where we left off. Let's talk about today declaring exceptions in a throws clause. So declaring an exception. If a method does not declare an exception, then in most cases it must at least warn programmers of any invocation of the method that might possibly throw an exception. You know, we looked at it last time, division by zero. Pretty easy one to recognize. This warning, of course, is what's known as a throws clause. And including the exception class in a throws clause is called declaring the exception. For example, a method that might possibly throw a division by zero exception and that does not catch the exception would have a header similar to the following. Public void sample method throws division by zero exception. The part throws division by zero exception is a throws clause stating that invocation of the method sample method might throw a division by zero exception, meaning you're probably doing some kind of fractional operation. It's a possibility your denominator could be zero. Right. When we look at the throws clause, if there's more than one possible exception that can be thrown in the method definition, then the exception types are separated by commas as what's illustrated below. Public void sample method throws division by zero exception, comma, some other exception. So if you have a possibility, let's say, of having division by zero and let's say an input mismatch, so you think somebody might accidentally enter a character instead of a number, put that there to help catch that exception. Now, most ordinary exceptions that might be thrown when a method is invoked must be accounted for in one of two ways. Either the possible exception can be caught in a catch block within the method definition, or the possible exception can be declared at the start of the method definition by placing the exception class name in a throws clause and letting whoever uses the method worry about how to handle it. Now, this is what's often known as a catch or declare rule. In any one method, you can mix the two alternatives, catching some exceptions and declaring others within the throws clause. Now, we've already known about the third technique, handling exceptions within a catch block. We've done lots of those. The second technique is kind of a little bit more of a form of shifting responsibility. So, for example, suppose your method has a throws clause as follows. Public void, your method throws division by zero exception. In this case, your method is absolved of the responsibility of catching any exceptions of type division by zero that might occur when your method is executed. If, however, there's another method, let's call it my method, that includes an invocation of your method, then my method has to handle the exception. So my method would have the exception handling inside of it. Now, when you add a throws clause to your method, you're saying to my method, if you invoke your method, you must handle any division by zero exception that is thrown. So, in effect, your method has passed the responsibility for any exceptions of type division by zero from itself to any method that calls it. So, it's kind of a passing the responsibility from you to the person invoking that. Of course, if your method passes responsibility to my method by including a division by zero exception in the throws clause, then my method may also pass responsibility to whoever calls it by including the same throws clause and definition. So if your method has the throws division by zero exception and my method has division by zero throws exception, then if someone goes and wants to use my method, they now have the responsibility of handling the division by zero. However, in a well-written program, though, every exception that is thrown should eventually be caught someplace by a catch block in some method that does not simply just declare the exception class in a throws clause. You can't pass the buck forever. Eventually, somebody has to come in and own up the exception here. Now, when an exception is thrown in a method but is not caught in the method, that pretty much immediately ends the method invocation. All right, just like how we saw with our try catch blocks when we first started talking about this chapter. Once you get a thrown exception, it stops executing the code within the try block and it goes to the catch. Now, be sure to note that the throws clause for a method is for exceptions that pretty much would get outside the method. If they do not get outside the method, they don't belong in the throws clause. If they get outside the method, they belong in the throws clause no matter where they originate. So, let's kind of look at this way. If an exception is thrown within a try block that's executed inside of a method definition and is caught in a try block inside the method definition, then its exception class need not be listed in the throws clause because you're handling it all within inside that method. However, if a method definition includes the invocation of another method, and that method can throw in an exception that is not caught, so that's like the my method, your method that we just talked about, then the exception class of that exception should be placed within the throws clause. All right, let's just take a moment to recall safe divide here from last lesson. In the division second demo version, we rewrote the program from division first version so that the exception thrown is in the method safe divide. And I kind of mentioned this actually a little bit when we looked at those two classes side by side. The method main include a call to the method safe divide and puts the call then in a try block. Because the method safe divide can now throw a division by zero exception that's not caught within the method safe divide, we need to declare this in a throws clause at the start of the definition of safe divide. If we set up our program this way, okay, in the case in which nothing goes wrong, it's completely isolated, it makes it a lot easier to read. And it's not cluttered by try and catch blocks. So let's just take a moment just to review that here. So I'm going to pull first version back up just so we can see those. And if you remember, this was the original try block right here. So we had this whole big chunk right here. If we look at the second version try block, it's a little bit smaller, right? And it's simply because we call this method safe divide here. So safe divide pretty much eliminates it down a lot of this here for us, because now it just goes to this print line. So we pretty much took this right here and moved it into this method safe divide. All right. And just simply just says, if bottom equals 0, throw new division by zero exception. Otherwise, return top divide by bottom. Simple. All right. But right here is where we have to throw that exception, because before, remember we had it here. Here's where the throw was before. Because that throw is not there in our try block, when we do our method, we have to put the throw there. All right. So that's kind of the big difference. Now, can you still technically do it this way? Yes. All right. There's nothing illegal about doing it this way. Is this way a little bit nicer to look at? Definitely, because if you look at your main method, I don't have to look at a bunch of try, catch, throw statements. I have a try and I have a catch, but that's about it. All right. Now, obviously, we've talked a little bit about the catch and declare rule. But our next lesson is going to explain exactly which exception classes are subject to that catch and declare rule. A good way to kind of look at this, though, is the compiler will assure you that you follow the catch and declare rule when it is required. So if you're not quite sure whether a class is subject to catch or declare, you can always rely on the compiler to tell you. So if you use a class that is subject to catch or declare and you do not follow the rule, you're going to get a compile error message. All right, Eclipse is going to yell at you and say, there should be something here for it. All right, and that's going to wrap it up for today, folks. So until next time.